Okay, on the blog there were questions about problems number 7, 8, 10, 11C, 12, and 13. So I'm going to go over those, probably over number 12 a lot more, because on problem number 12 we're going to learn something slightly new that you'll need for tomorrow. So for right now I'd like you guys to, I'm going to give you some hints. We're going to go over some things, and hopefully you guys will be able to answer all these questions. For problem number 7, I think really the main issue there is that there's a typo on the problem. This said dy dx on your paper. It should say dy dt. And the reason for that is here we have xy equals 10. If I change that and make it y equal 10 over x, you guys should be able to find dy dx. Okay. Then once you find dy dx, which you can find pretty quickly, you have to know that at x equals 2, you should be able to find what dy dx is. It should give you a value. And then all we have here is that, well, dy dx, you're going to get dy dt, you have. The question is, what is dx dt? Right? That's the question. When you figure out dy dx, plug in x equals 2, and that'll give you a value for dy dx. And you'll put that here. So you have some value. That's going to equal 3 divided by dx dt. And once you have that value, solve for dx dt, you should get one of these numbers. So that is your help for problem number 7. Okay, now on to problem number 8. A common thing that I saw in these problems that were asked was you do need to always ask yourself the question, what do I have? What do I need? And can I get what I need with what I have? I don't know if that question has been asked, but seriously, in all these problems, you need to ask yourself those questions. Here, it's giving me x and y in terms of t. It's asking for the slope of the tangent line to the curve. So a couple of things that we're looking for is slope. That's dy dx. Now, how do I find dy dx? Well, if I have a function in terms of x, I derive it. But here I have two functions in terms of t. We learned that dy dx in that case is dy dt divided by dx dt. So since they're asking for the slope, that's exactly what I'm going to do. Dy dt is the derivative of t times e to the negative t. So the first thing you have to remember is what you have. You have a product there. So we need a product rule. So it's going to be t times negative e to the negative t plus 1 times e to the negative t. That's our product rule. Divided by dx dt, which is just e to the t. Okay. If I were to clean this up, this would look like negative t plus 1 all over e to the 2t. And all we did here was we wrote e to the negative t as a denominator. And since these were common denominators, we put them all together. Just remember that e to the t times e to the t is e to the 2t. Okay, now here's we approach our second problem, which is this is dy dx in terms of t, and then when dy dx where x equals 3. So again, you ask yourself, what do I have? What do I need? Well, I need a t value, because the only way I can figure out dy dx is if I have a t value, and they gave me an x value. So is there anything in the problem that gives me from an x value to a t value? And there is. It's right here. So I'm going to say when x equals 3, what does t equal? Because from this equation, we get that 3 equals e to the t, which means that t is going to equal the natural log of 3. This is why this was a calculator problem, because I need that to find it. I know that dy dx now equals negative natural log of 3 plus 1 divided by e to the 2 times the natural log of 3. Plug that in, and you should get an answer. For number 10, again, we should have the whole class say this together. We gotta ask ourselves, what do I have? What have I been given, right? What do I need? And do I have the tools to get me there? As the particle moves in the xy plane, so the position of the particle is given by these two functions, x in terms of time and y in terms of time. The question is find the velocity vector. Okay, so already we know something. If they give me a position vector, I can find a velocity vector by deriving each one of these. So it shouldn't be a problem. So let's do that real quick. Velocity vector is going to be the derivative of those up here. So the x component of the velocity vector is going to be 5 plus 3 cosine of t. And the y component of the velocity vector will be the derivative of this. Again, we have a product rule. So that's going to be 8. Sorry, just kidding. Product rule, so that's going to be the derivative of 8 minus t, which is negative 1, times 1 minus cosine of t, plus 8 minus t times sine of t. Okay, so here we have my velocity vector. Shouldn't be a problem. Then it says find a velocity vector at the time when the particle's horizontal position is x equals 25. So just like problem number 8, we have a similar problem here where they give me, well, we found our answer in terms of t, but they didn't give me a t value, they gave me an x value. So again, what do I have? Can I get from an x value to a t value? And yes, I can, because this is the horizontal position. That's this function here. You have to remember that when it says x of t and y of t, this means the x value, this means the y value. So all they're saying is that 25 is my x value when I have 5t plus 3 sine of t. And this is where, again, the calculator comes in. You need to solve this. One of the best ways to solve it is if you have a TI-89, you just put solve 25 equals this function, it'll solve it for you. Or if you have a TI-84, you're going to put one in y1, the other in y2, and find where they intersect. We will find that they intersect somewhere around t equals 5.44576. Okay. Now, once you find that t value, again with the calculator, plug that in here, and you should get your answer. Okay, now moving on to problem number 11C. A couple of things we want to do here. It says find dy dx as a function of x. There's two ways we can do this, and I'm going to do this two different ways. Since it says as a function of x, we want to make sure that our answer looks like and sounds like dy dx equals lots of stuff with x's in it. So let's see where we're at. We're given again x and y in terms of t. Asked for dy dx, so I know that that's going to be dy dt, which is the derivative of this function. So it's going to be 2p squared divided by, let me write that here. So we know that dy dt equals this, divided by dx dt, which will be 2t. Or in other words, that dy dx equals t. Again, we find the same problem. We have dy dx equals t, and they want this in terms of x. Is there anything here that gives me a function that's connected for x and t? Yep, right here. right? So all we have to do is solve for t. Well, if x equals t squared minus 3, what does t equal? T will equal the square root of x plus 3. I don't have to put minus square root of x plus 3 because this is saying that t is greater than or equal to 0. So I'm going to leave it as t equals the square root of x plus 3. That being the case, dy dx equals the square root of x plus 3. That's one way of doing it. The other way of doing this problem is that we actually we find a function that looks like this: y equals some function in terms of x. Well, the way we do that again is what we did about 3 or 4 days ago, which we're going to solve for t. So you know that t is the square root of x plus 3. Plug that into this function. So we get y equals 2/3 of the square root of x plus 3 to the third. Notice now we have a function, y function in terms of x. I'm just going to rewrite it here. X plus 3 to the 3/2. Alright, how do we find dy dx? Well, we derive this function. 3/2 times 2/3 is 1, so it's x plus 3 to the 1/2 times the root of the inside, which is 1, or in other words, dy dx is the square root of x plus 3. Notice either way, we'll get the same answer. That's problem number 11. Okay, for problem number 13, I know I skipped 12, we're going to do that here in a little bit. For problem number 13, I just want to talk about these for a second. dy dx, it's just dy dt over dx dt. So I think you can find those and solve that one pretty quickly. B, find an equation of the tangent line. Again, my equation is going to be y minus y1 equals m times x minus x1. So where you get your values from, notice we need a y1. We're going to need a y1 and m and an x1. Well, t equals pi over 4. Again, what do you have? What have you been given? From a t value, can you get a y value? Yes, right here. From a t value, can you get an x value? Yeah, right there. And then can we get slope? Well, you just found out what slope was here in A. So using that t value, find your slope, you have your equation. Now I do want to talk about this last problem here. Since the curve C intersects the y-axis twice, what you need to remember is the y-axis is any value when x is 0. So anytime it crosses the y-axis, you know that it will cross the y-axis at a point, and you know that that point will have the x-coordinate be 0. So that was the tricky thing with that problem. We have to know is x has to be 0, or like I wrote here, that 2 minus 3 cosine of t has to equal 0. Again, just think about that. You can discuss this in class. Why do I know that? Well, it crosses the y-axis. The y-axis always has the x-coordinate being 0. You don't know what the y value is. You just know the x value is going to be 0. So knowing that then, we'll know that it crosses when the cosine of t equals 2/3. They've been pretty nice to us, and they told us that t is a value between negative pi over 2 and pi over 2. Hopefully this next sentence makes sense to you. What this means is that t is some angle that's either in the first quadrant or the fourth quadrant. So when it says cosine of t is 2/3, that's going to give me two different angles, one in the first quadrant, one in the fourth quadrant. You got to solve for that using your calculator. When it says approximate the length of the curve between the two y-intercepts, well, all you're going to need there is your equation for the length of a curve. This right here will give you two t values. You'll find that t equals, we'll say, a and b. Once you have that, approximating the length of the curve between the two y-intercepts will just be your um, equation for that, which is the integral from a to b, the square root of dx dt squared plus dy dt squared dt. Again, where do we get these from? You have dy dt here, you'll have dx dt here. Set it up. You can use your calculator for it, and you have an answer. Okay, we are going to spend a little bit of time on number 12 because I do need to show you there's two ways of doing this. Again, they've given us dx dt, dy dt. I can figure out slope. I can figure out, since they give me, this is pretty much the velocity components of the components of the velocity vector. I can find the components of the position vector by anti-deriving. I can find the acceleration vector by deriving this. So it depends what they ask me. It says that A, find the coordinates of P in terms of T. Coordinates, that's the actual position. So that might have been a problem. Coordinates means the position of the point P in terms of T. So we're going to have to anti-derive. So here's how we do that. That means that x of t is going to equal the antiderivative of 1 over t plus 1 dt. And this is the notes that I gave you yesterday. You needed to remember that when you're anti-deriving, you always need a plus c. Notice there aren't any bounds here. In order to do that, we have now this will equal the natural log of t plus 1 plus c. And that's my x of t. For y of t, that's going to equal the antiderivative of 2t dt. Or in other words, that y of t will be t squared plus c. Okay. Now, they gave us some more information again. What do I have? What have I been given? What can I do with what I have? It says t equals 1, x equals natural log of 2, y equals 0. So what that means is that when t equals 1, I have that x of 1 equals natural log of 2 plus c. And it told me that x was the natural log of 2. So that means that the natural log of 2 equals the natural log of 2 plus c. Or in other words, that c equals 0. Therefore, x of t is going to equal natural log of t plus 1. Similarly, they told me that y of 1 equals 0, and that equals 1 squared plus c. In other words, c equals negative 1. Therefore, y of t is going to be t squared minus 1. So notice now they've given me these, with that problem, I've been able to find the equations for x and for y. Okay, here's where the new part comes in that I need you guys to learn and pay really close attention to, because you'll definitely need this for tomorrow. And here's the new part. The new part I need you to learn. Obviously, you didn't need this for this problem. It just says find the coordinates of p in terms of t. Here are the coordinates of p in terms of t. So we're done with this problem. But what I need you to learn is this. What if they would have asked you, okay, find the coordinates when t equals 5. So I'm put here. Now find p, right? So find the points when t equals 5. Well, according to this problem, all we'd have to do is plug in t equals 5 here and here, and we have a coordinates. No problem. Where does the problem come in? This function was easy to find its antiderivative. We know the antiderivative of 1 over t plus 1 was this, We knew the antiderivative of 2t was this. We were able to solve. Tomorrow and on other problems, they're going to give you the same information, but you're not going to be able to antiderive, meaning this, that dx dt and dy dt are going to be functions that you cannot antiderive. Or in other words, that you'll plug, that you don't have a rule for antideriving. Even with the TI-89, you'll plug it in and it won't be able to solve it for you. So how do we find that problem then? There. Well, here's what you need to do. You need to remember that at t equals 1, your given is that your point is natural log of 2, 0. Okay. Now what we're going to do is, even though we can't antiderive it, your calculator will be able to find a definite integral for it. So what I want to do is I want to find the definite integral from 1 to 5 of, let's try our x value of, or x of dx dt. Okay. Again, we're assuming that there is not an antiderivative for dx dt. But let's find out that you plug this into your calculator, and this gives you the answer of 7 for some reason. And let's say that when you do that from 1 to 5 of dy dt, that will give you an answer of, let's say, 4. I know this may be a little confusing. What I need you to realize is that there are going to be problems where the antiderivative cannot be found, but the definite integral can. You just gotta trust me that there are functions like that, where you try to find the antiderivative, there's no rule for it. The calculator can't help you even if it's the TI-89 or TI-84, but yet when you do the definite integral, that will give you a value. Okay, so again, we're assuming we have some crazy functions here where we can't antiderive. Alrighty, well let's say that the integral from 1 to 5 is 7 for the x coordinate, and from 1 to 5 is 4 for the y coordinate. Question still is, what is the point when t equals 5? What we need to understand is all we found here is that the total change from 1 to 5 for the x coordinate is 7. And if you knew an original point at t equals 1, that t equals 5 is going to be our previous point plus the total change. Or in other words, it'll be natural log of 2 plus 7. And our y coordinate is going to be 0 plus 4, or in other words, 4. Okay. This is the slightly new part that you have to learn. Still the same idea. If you have an x coordinate and a y coordinate for the velocity, how do you find the position you antiderive? Every once in a while you'll be able to antiderive. Remember, solve for your plus c, and you have your equations. Every once in a while you won't be able to do that. It still involves the idea of the antiderivative, but now it's called the definite integral. You have to remember the definite integral gives you the total change from a to b. You just have to apply that to the previous point. Okay. Alrighty, so you'll have to remember that. If you have any other questions on that, if you want a different problem to work with that, ask me and I will write up a different one tonight. But you'll definitely need this for tomorrow. Okay, moving on. Okay, once you did this difficult part, which is finding a x coordinate and finding a y coordinate for positions, let's write an equation expressing y in terms of x. So I'm going to help you with that. X equals natural log of t plus 1. Solve for t first. That means that e to the x will equal t plus 1. Or in other words, that t equals e to the x minus 1. Plug that in here. You should get your y in terms of x. And that's b. C find the average. He says find the average rate of change for y with respect to t as with respect to x as t varies from 0 to 4. So two ways of doing this. I'm just going to go the easier way. We want the average rate of change. You have to remember the average rate of change is f of b. I'm going to have a f of b minus f of a all over b minus a. Notice here that I need change in y over a change in x. Change in x is I need a b value and an a value for x. And it told me t varies from 0 to 4. So again, I think we've done this for a few problems already. I need x, they've given me t. Do I have a function that gives me a connection between t and x? And I do. It's this one right here. So that means I need to figure it out from natural log of 5, right, plug in 4 in, minus the natural log of 1, which all of you know is 0. So in other words, my change in x is going to be natural log of 5. Okay, how about f of b minus f of a? Well, here you have your function that you found. Plug that in here, and you'll have your average rate of change from t equals 0 to t equals 4. And that's C. For D, find the instantaneous rate of change of y with respect to t to x when t equals 1. Instantaneous rate of change. This one's actually the easiest problems for all of this, because all they want is dy dx. And you already learned a long time ago that dy dx is dy dt over dx dt. You're going to get some function actually in terms of t. Find it when t equals 1. Just plug that in, and there's your answer. Okay, have fun. What I'd like you to do is make sure you understand all of these problems from 1 through 13. Tomorrow you're going to have a rather quick little assessment, 10-question assessment on all these things that you'll have to remember. You'll have to remember definitely this, the dy dx is dy dt over dx dt, and all the applications that go with that, meaning that if I give you an x and a y equation in terms of t, can you find dy dx? If I give you a dy dx and a dx dt, can you find dy dt? All that stuff. Also, you have to remember your horizontal tangent and your vertical tangents. Remember that horizontal tangents are when dy dt is 0, vertical tangents are when dx dt is 0. You have to be able to do that. Next thing you have to remember is you'll definitely have to remember your distance formula, or in other words, let me not write distance, but things you have to remember. Remember the length, right? Length of arc. That's when we did one of these problems, the integral from a to b of dx dt squared plus dy dt squared. So you have to remember that. You're going to have to remember, if I give you a position vector, how to get the velocity vector and acceleration vector. You have to be able to do that. Let's see what else. Basically everything that we've done, problems 1 through 13. And there will be one problem where, again, we talked about, you'll have some crazy dx dt's, dy dt's, but you'll still be able to find the position at a certain point using a definite interval. Okay, so have fun today and tomorrow.